Okay, we're on to the problem solving questions, the context and application questions. Okay, so we're going to start here with question 7. Question 7 is worth 60 marks, so it's actually the most valuable question in the entire paper. Okay, here is the context, the story. Marcus is in charge of restoring an old theatre. He is replacing the stage and has been given a plan for the typical dimensions of a theatre stage. The plan of the stage is in the shape of a rectangle joined to a semicircle. The length of the rectangular part is 2x meters and the width is y meters. The diameter of the semicircular part is 2x meters. Use the perimeter of the stage is 80 meters. Okay, using the fact that the perimeter is equal to 80, show that y is equal to 80 minus 2x minus pi x over 2. Okay, typical kind of context and application question in that it starts off with a lot of information in there at the start, a lot of English in there. So I know for some people they like it and other people are the opposite. They find it a bit difficult. So I'm going to say the first 2 sentences, they're the context, but mathematically they're not that important. What's important is the idea that the shape is a rectangle joined to a semicircle. Okay? The length of the rectangular part is 2x meters, so the length is 2x meters. The width is y meters. The diameter, okay, so the diameter is also 2x meters. And now we're told the perimeter equals 80 meters. Okay. Using the fact that the perimeter is 80, okay, so we're going to use that. We're going to show that y is equal to 80 minus 2x minus pi x over 2. So again, some of you here might be looking at this. When you looked at it first in the exam, you might be thinking to yourself, oh my God, this is a very difficult question. But what I always encourage people with this is, okay, you just got to read it a couple of times. You got to take your time with it. Okay, we got somewhere to start. We're talking about perimeter, so let's see what we can do about the perimeter. Okay, we got a semicircle and rectangle. So we know the circumference of a circle is 2 pi r, so the circumference of a semicircle is 2 pi r over 2. So that's pi r, okay? But we know that the diameter is 2x, so the radius is 1x. So therefore, my circumference is pi times x, okay? I know that the rectangle has a perimeter of 2x plus y, because this side over here is also y, but naturally the broken dotted line there is not part of the perimeter of the actual, well, it would be part of the perimeter of the rectangle. It's obviously not part of the perimeter of this theatre stage. So down here we are, perimeter equals 2x plus y plus pi x equals 80. You're keeping an eye on what you want here. You want to get y on its own. So we work towards that 2y is equal to 80 minus 2x minus pi x. I divide everything by 2. I get y is equal to 80 minus 2x minus pi x over 2. I have a look back at my question. Hey presto, it's the answer. I got there just by step getting y on its own, and it's 10 marks.
So this one is marked 0, 4, 7, 8, 10. So low partial credit here, which is your 4 marks, is forming an equation involving 80. So, or forming a perimeter equation. So if you algebraically found the perimeter equation, so you had the 2x plus y plus pi x, and you made that equal to 80, or you had a different perimeter, you made a mistake on the perimeter, but you involved the 80, that's where you're getting the low partial credit here for 4 marks. Mid partial credit is manipulating your equation to try and isolate the y. So if you got to the 2y equals 80 minus 2x minus pi x, or if you had a mistake on the equation, but you then manipulated your equation to try and isolate the y, that would get you mid partial credit. And then your high partial credit would be isolating y, but you don't get the right answer for whatever reasons. You had a mistake earlier on, or you accidentally, when you divided by the 2, you missed off something on the top of that fraction. Whatever that mistake may be, as long as you have it as y equals, you would get high partial credit at that point. Obviously, full credit then is for the correct manipulation and isolation of y.
Okay, Andrea, thanks very much. So we've got A part 1 done, 10 marks. Okay, hence, so as soon as we're seeing hence, we're thinking to ourselves, right, we're going to use that first answer. Even if we didn't figure it out correctly, we're going to use it to show that the area, which is A meters squared of the stage, is given by our formula here. Area is equal to 80x minus 2 plus pi over 2 x squared. Okay, so let's have a look at it. Well, we know that our area is equal to pi r squared over 2. Okay, why is that? That's the area of the semicircle. Well, we know the area of the circle is pi r squared, so we're going to divide that by 2. Our area of the rectangle, well, that's very straightforward. It's just 2x times y. So our area is equal to 2xy plus pi x squared over 2. Okay, so we're keeping an eye down on our answer here to say, okay, let's have a look at our answer. In our answer, there's no y, and it also mentions the word hence. So we're thinking to ourselves, we got to use our answer from part 1 to simplify this down for part 2. Okay, so what are we going to do? We're going to sub in 80 minus 2x minus pi x over 2 for y. Straight away here, you can see the 2's will cancel. We have a 2 at the top and 2 at the bottom. Okay, so we got 80x minus 2x squared minus pi x squared plus pi x squared over 2. So again, you're looking down at your answer. You're saying, okay, the 80x is exactly how I want it. So that's not too bad. We just have to tidy up the rest of this bit. Okay, what do I have here? This little part here could throw a few people off, but you've got minus 1 pi x squared plus pi x squared over 2. But if I just said to you, I'll just write this over here to the side. I write it up here at the top, just so everyone knows it's different from the actual question. My maths teacher used to call it an aside. So minus 1 plus a half. Like minus 1 plus a half is minus a half. So with our question here, we got minus 1 pi x squared plus a half pi x squared. That's what we have. So that becomes minus a half pi x squared, or how we write it is minus pi x squared over 2. So we still have our minus 2x squared. And now I'm keeping an eye down on my answer again. I'm going to factorize out an x squared on the right-hand side. And okay, just because the way it's asked the question, I'm basically factoring out a minus 1 here. And some people will find this line a little bit tricky, but what you've done is you've taken into account there's a negative sign here, a negative sign here. You factor out a minus 1, and then both terms inside the bracket will be positive. Okay, and if you're looking at it and you're a bit unsure, just try multiplying out that bracket again, and you'll see you get back to where you wanted to be. So let's have a look. 5 marks for that. Okay.
So the marks we're looking at here is 0, 2, 3, and 5. So 2 marks for your low partial credit is forming an area equation. So if you got your 2xy plus pi x squared over 2, that's forming an area equation. If you actually only wrote down 2xy, you could still have low partial credit there because you have formed an equation involving an area. So that's your 2 marks. Your 3 marks then for high partial credit is substituting y into your area formula. So if you got the area formula right, brilliant, your working would look the same as you've just seen. If you got it wrong, but you still substitute y in correctly, you can still pick up high partial credit here. So if you wrote your area was just 2xy, you substituted in the y from the previous part correctly into that, you could pick up high partial credit here for 3 marks. And then the full 5 marks are for getting the answer in the form that it's asking you to.
Okay, so perfect. So, we'll say the algebra in there, some people would have struggled with, but because you have the answer given to you at the end, that you know what the answer is, you can still continue on to A part 3. So we know the area is 80x minus 2 plus pi over 2x squared. Now, it says use calculus to find the value of x at which a is a stationary point. So, okay, there's a bit of vocabulary in there. Calculus, you hopefully know, is differentiation and integration. So, for us, in this case, hopefully you're going to spot that it's differentiation. The stationary points are going to be the max and the min. Even if you aren't 100% sure on that, you're going to say to yourself, you're going to have to do something. And part 4 mentions maximum. So you're going to say to yourself, okay, let's differentiate. Now, when you differentiate here, again, it might look a bit tricky, but it's actually not too bad. Because what are you doing here? This is x to the power of 1. When you multiply down by that and reduce the power by 1, 80 x to the power of 1 becomes 80. What's happening here is all this guy is just a constant, 2 plus pi over 2. So if you do that, if you put that into the calculator, it's going to give you a number, 3 point something. And what you do, you're just multiplying down by your power. So again, you're just multiplying down by your power, reducing your power by 1, so you get minus 2 times 2 plus pi over 2x. And again, you can have all this in decimals if you want. Okay, that is my first derivative. It simplifies down to 80 minus 4 plus pi when you multiply through the 2, and that's times x. So minus 4 plus pi times x. That's my first derivative. Okay, I'm looking now at my question, part 3, part I, and I'm saying to myself, okay, what am I going to do here? We always know that a max or min, a stationary point, occurs where the first derivative is equal to null. So we get 80 minus 4 plus pi x is equal to 0. I'm going to solve this by isolating my variable, and I have it. X is equal to 80 over 4 plus pi. It's a 10-mark question.
So the marks on this one are 0, 4, 7, 8, and 10. So low partial credit here is work of merit. So that means you've tried to differentiate, maybe you've made your differential incorrect, you've had a problem with it, but you might have one bit of it correct. That would be work of merit. So if you differentiated and you got the 80, and then the rest, there might be a mistake later on, but just that 80 would count as work of merit because it is correct differentiation of some sort. That's your low partial credit for 4 marks. 7 marks, which is your mid partial credit here, is either a fully correct differential, so you got to the 80 minus 2 bracket 2 plus pi over 2x, so fully correct differential, or you made a mistake on your differential, but you knew you needed to make it equal to 0. So you have an incorrect differential equal to 0. That would be your 7 marks here for mid partial credit. And then high partial credit on this question is 8 marks, and it's for a correct differential equal to 0. So if you got to the point where you had your 80 minus 4 plus pi x equals 0, that is high partial credit. And obviously then full credit is for going on and getting the correct answer.
Very good. So I can imagine some students out there who've been finding this difficult. They're finding the maths here in question 6 difficult. But when you look at your marks, you might still be doing okay because you're picking up the low partial credit, the mid partial credit, and you're still in the question. Okay.
Absolutely.
Yeah, and Andrea, I know from seeing this, we've seen that plenty of times in the past, haven't we? That students who might be struggling in a question, when they look at their marks at the end, they're not doing too bad.
Oh, absolutely. And like Owen always says, you do what you can. I suppose my mantra that I always go with is you write something down because you try every single question because marks are there to be given. When we examine the papers, when we're marking papers, we're looking to try and award marks for correct maths, and you'll have seen as we're working through this, there are places that the marks are given, like on that previous one, you'd be getting 4 out of 10, 40% of that question right if you just differentiated 80x to 80. Like that's a lot of marks to pick up in a massive change between grades,
Absolutely. And here we are now. Once we have our answer for part 3, it says prove that the value of x you found in part II. Now, thanks to the student who emailed this in correctly, it should say part III, but I don't think it would have thrown anyone off because it was obvious that it was the answer you had would give you the maximum value. Okay, would give you the maximum value. So the answer from the previous part, when you get so we had our first derivative was d dx is equal to 80 minus 4 plus pi x. When you get your second derivative, d squared a dx squared, so your second derivative is minus 4 plus pi, and that is less than naught. Okay, that's less than naught. And so therefore it is a maximum value. You're dealing with a maximum because the second derivative is less than naught. So you didn't actually have to do any more than that to get the marks, and the marks were 10 marks for that.
So this one's marked 0610. So it's a partial credit available if you did any work of merit to find the second differential. So if you've attempted to differentiate the first differential to get the second differential, you would get work of merit there, which is partial credit for 6 marks. And then obviously you need to have got that right and stated that it is a negative to get the full 10 marks. So in terms of the work of merit there, if you got rid of the 80, because you know that when you differentiate 80, that would count as work of merit towards the finding the second differential.
Okay, and I imagine there could be some students out there who possibly went a different way with this because they misinterpreted, or they interpreted the part where it's saying found in part II, and they might have tried to do something different perhaps there. Again, remember, this is the part now where you're looking to see, did you do a work of merit? And in this case, you can try to judge it for yourself that if you did, you're going to get 6 out of 10. If you're unsure, this might be one where you're emailing us, and we're going through this then in the part where we go through the fine details of the marking scheme, just the part of like, what do I get for this? Do I get 6 or do I get 0 in this case? But in this one, we'd be erring on the side of the student here, because there was a little room for doubt in the paper itself. Andrea, am I on track there with that, do you think?
Yeah, absolutely.
Yeah, so just on this one, you'd be kind of giving yourself the benefit of the doubt in this one. Okay. So what are we going to do? Calculate to the nearest meter squared the maximum area. So if we have the value of x, which gives us the maximum, that's 80 all over 4 plus pi. I'm summing that in for x in here, and at some point here, you're going to be putting that into the calculator, and you're going to get 448 meters squared. It's a 5-mark question.
Okay, so this one's marked on 035. So partial credit here is substitution in of x. That can be an incorrect x. So if you got part I wrong, but you substitute that answer in here, then you can still pick up the partial credit. And similarly, you can pick up the full credit. If you've put in the wrong value of x, but you've worked it out correctly, you can get the full 5 marks here, as long as what you've substituted in comes from your part 3. So it's a follow-through mark. This is a starred question, so that means there are 4 marks available, and those 4 marks available is if you incorrect units and or incorrect rounding. So if you're not penalized twice for that. So if you've missed off both, you still get the 4 marks. Okay? So incorrect rounding, incorrect units, it's a starred question, 4 marks available.
Okay. Now the next thing I'm going to say is very important for the real exam. Okay? You're going on to part B. Now the context of the question is still the same. It's talking about Marcus, it's talking about the theatre, but really part B is a separate part to part A. So to a certain extent, you can forget about part A when you're doing the rest of this question, because it's dealing with a different function. A bowl is put down to catch, so Marcus has found a leak. And a bowl is put down to catch the water, and Marcus watches it filling as he waits for the leak to be fixed. The depth of water H, okay, the depth of the water is H meters, the volume is meters cubed, and it's given by this. Volume is equal to 1/12 pi H squared times 3 minus 4H. And we can see that H, the domain for H is 0 less than or equal to H less than or equal to 0.25. Find in terms of pi dVdH. Okay, so you're seeing dVdH, the rate of change of the volume with respect to height, how the volume is changing as the height is increasing in this case. And we're given a value here, H is equal to 0.1. So what are you saying? Well, you're looking at a function which is in terms of height, okay, for volume, we're going to have to differentiate that function. When we differentiate that function, well, what I've done beforehand is I made it a little bit easier for myself by multiplying through 1/12 pi h squared times 3 gives me a quarter pi h squared. 1/12 pi h squared times minus 4h is minus 1 over 3 pi h cubed. Okay, I'm going to differentiate now. So I haven't differentiated yet. This is the part where I differentiate. dv dh is equal to 1 over 2 pi h minus pi h squared. Okay, I've multiplied down by the power, reduced the power by 1. And now, at this point, I'm going to put in h equals 0.1. So dv dh is equal to half times pi times 0.1 minus pi times 0.1 squared. Pi over 25 equals 0.04 pi, and it's a 10-mark question.
So on this one, we're looking at 0, 4, 7, 8, 10. So low partial credit for 4 marks is any correct differentiating step. So you've differentiated anything correctly, you can have 4 marks here. The mid partial credit is for correct differentiating and you have most of the differential correct. So maybe you have one mistake within your differential, but the vast majority of it's correct. You can also answer this question using the product rule. So had you not multiplied out up at the beginning, you could use the product rule to be able to differentiate this function. And some correct use of the product rule here would also be mid-partial credit. And that's for 7 marks. High partial credit here for 8 marks is the correct differential, or your answer is correct but not in terms of pi. So if you have worked that out but not left your answer in terms of pi's, you might have thrown the VDH all into the calculator and come out with the decimal at the end. That would be high partial credit here because the question does ask for it in terms of pi, and that's for 8 marks.
Okay. So, not the easiest question, but at the same time, if we were starting from scratch here, really all you had to do was differentiate V in terms of H. It's leading on to the second part. The water flows into the bowl at a rate. Some of you were probably waiting for this moment to the rate of change. Okay, so as soon as you see rate, it's going to be, it's likely to be a rate of change question involving differentiation. So a rate of pi over 800 meters cubed per second. So the water is flowing in, and obviously it's increasing the volume at that rate, pi over 800 meters cubed per second. Find the rate of change of h in meters per second when h is equal to 0.1. So as I always say to students, there's an implication in this type of question. It doesn't say it, but it implies it. Find the rate of change of h implies with respect to time. So how the height is changing as time changes. So what we want to find is dh dt. What we have from our introduction is we have the rate of change of the volume with respect to time, dv dt. So dv dt is going to be the pi over 800 meters cubed per second. And we've already found, we've one little bit of work to do with it, but we already know dv dh is 0.04 pi. So let me maybe just have one look down here again at this point. So what we're looking for is dh dt. Okay, so using chain rule, I can say that's dh dv times dv dt. Okay, we know from our previous part that dv dh is 0.04 pi from part I. So I need to invert that because I can say that's 0.04 pi over 1 for dv dh. So dh dv is 1 all over 0.04 pi. dv dt is pi over 800. The pi's cancel and I get over 32 meters per second for my rate of change of height with respect to time. And it's a 10-mark question.
So this one's also marked 0, 4, 7, 8, and 10. Low partial credit here for your 4 marks is for the use of the chain rule, knowing that dH/dt is equal to dH/dV times dV/dt. So if you have that written down, so the first bit there in red, that's your low partial credit there for 4 marks. For mid partial credit, it's correctly knowing that dV/dt is pi over 800. So if you have that written down at all, so if you write down dV/dt equals pi over 800, that's mid partial credit for 7 marks. High partial credit is correctly substituting into your dH/dt. So inverting the dV/dH to get your dH/dV, multiplying it by the pi over 800, which is your dV/dt, and that correct substitution gets you the 8 marks. Finally, your correct final answer is the 1 over 32. That is a terminating decimal, so if you have it as 0.03125, then that's fine too. Units are not needed for full credit here.
Okay, and that actually brings us to the end of this question. So I know that students would often find that question to be a bit tricky. There's a lot of, we'll say, algebra in there, and it's a bit abstract. Maybe some students find it a bit tricky because pi is running through the entire question. But I hope you see that after doing it, that part B was really a standalone question, and that for those of you who might have maybe not had much written down for part B because you found part A difficult, it's just something to learn for the next exam and the real exam when that comes. And just to mention again, just that bit of, just to give yourself the benefit of the doubt, if you were affected in any way by the little typo in that part of the exam paper. Okay, so with that, we're going to move on, and we're going to move on to question 8.